Myself, MALLESHAM DEVASANE. I am the faculty for computer science students, and welcome to Gradeup again. Yes, good afternoon everyone. Yes, we have 1 day left for the GATE exam. How are you feeling now, guys? Are you ready for the GATE exam? Of course, I am not here to make a trouble with the discrete mathematics. It's not the small subject to do the revision in 2 hours, but I will do what is the best possible for you. Yes. Yeah, good afternoon. Baneshri, good afternoon. Ara, good afternoon. Yeah, you are first. Agarwal, good afternoon. Yeah, Sahu, how are you? Yeah, Rajita Rao, good afternoon. Yes, good afternoon everyone. Sarita, good afternoon. Yeah, please share this video in our groups and also share to your friends. Please like the session if you are watching this video. And today I'm going to give you very good important guidelines for how to handle the discrete mathematics, but do not try to learn anything new today. That is my request to everyone, guys. Yes, Garima, good afternoon. Navneet, good afternoon. Renuka, good afternoon. Monica, good afternoon. Yes, Ariharan, good afternoon. Amit, good afternoon. Yeah, please answer me. Little bit nervous. Even I'm also nervous, guys, because you have 1 day left. I'm also worried about, and do not take this video as anything new to you. If anything that you have learned, if I'm making you revision, take it. If you do not understand, please ignore it. The first suggestion to everyone. Yeah, thank you, Pratik. Good afternoon. I love India. Yes, Sneha, good afternoon. Samir, good afternoon. Yes, Mukul, good afternoon. Yes, Pallavi, good afternoon. Yes, I'm going to come to the live again at 6 p.m. Please attend that session at least. If you are not able to attend this session, I know I should not conduct this session before the exam, but I'm only doing those people who want to do the revision. Just I want to give guidelines how to handle the discrete mathematics, but do not learn anything new in this discrete mathematics right now, guys. Take this video as a positive and make the positive energy inside you to handle the discrete mathematics. Yes, good afternoon. Abhishek, Akash, Mukul. Yes, understood. Mudita. Thank you so much for understanding my efforts, and thank you everyone who are joining from the last 4 days, and I'm very happy that that you are going to rock the GATE exam, and those people who are really working hard, I can guarantee you are going to perform well, because your efforts will never go into vain. And just believe in yourself. Definitely you can do better in the exam. If you are feeling the nervous, even other people are also feeling nervous, then take the advantage of that nervous to perform the well in the exam, guys. The nervous definitely there for everyone, but don't stop thinking good possible ways. Yes, it must be. Yes, it's not 3 hours class, guys. I'm going to take 1 to 2 hours class. I'm going to take 1 to 2 hours class. Remember that. I'm going to take 1 to 2 hours class. I know it is very difficult to attend this session because tomorrow you have an exam and you need to save your time. I know. I don't want to waste your time. I just give 1 hour guidelines for the discrete mathematics. Yes. Arman, I am for you. If you have a question, please come to the session 6 p.m. But take positively. 6 p.m. is a friendly session. I'm not going to teach anything at 6 p.m. And please don't forget to attend at 6 p.m. live session, guys. Okay. The Gradeup is one of the best platform for who are preparing for a GATE, ESE and PSU exams, and also if you are preparing for ISRO, BARC, UGC NET and all exams, that Gradeup is one of the platform where you have the best content available on the platform. Please install the Gradeup app and start preparing from today, guys. And this session is all-in-one revision class, but it is a short revision instead of master. It is just short revision class for the discrete mathematics. Yes. Thank you so much for realizing that yesterday's session was helpful. Thank you so much. For 2022 students, I'm going to bring the very interesting sessions on Gradeup. Please join the Gradeup if you are going to. Yes, Simon, don't worry about combinatorics. Don't worry about set theory, anything. Yes, please don't do that. Don't learn anything new now. If you want to know about me, I'm an educator. I'm a faculty who is having 12 years of experience and 12 plus still counting. My career started in GATE. Today I am able to deliver in GATE only because of I am living in GATE, I am learning GATE, I am teaching GATE, I am working for the GATE syllabus, guys. That is the reason I know what is happening in the GATE exam, because I have worked almost in all the institutes in India, almost, and also this is the second time I am working on Gradeup, and I am very happy to join again on Gradeup because I like the Gradeup, the environment. That is the reason I came back to my parent company. Yeah, so what I teach here: theory of computation, comparative design, discrete mathematics, programming, data structure and algorithms. Not all of them, but we have very good educators to handle some subjects here. We are going to share each other. Yes, the batch is going to start. Sorry guys. Yeah, the batch is going to start soon, and if you are attempting the paper tomorrow, definitely attend tomorrow a live session at 12:30 p.m. and 6 p.m. and if you are not aware of that, please come to the live tomorrow at 12:30 p.m. and 6 p.m. If you are attempting the paper, come first paper, come to the live at 12:30 p.m. after the exam, and if you are attending the paper at 3 p.m. you can also watch 30 to 40 minutes because we are going to give you what kind of questions are appeared in the first session. That's gonna help you. That's gonna help you. Remember that. So, but don't waste your time much on the live session because you are going for the exam. If you are watching for long time, it will affect the exam. So, I will recommend to go for 30 to 40 minutes just while doing the traveling or while you are going to the hall. Just look at what kind of analysis that I am going to provide tomorrow, guys. Okay, so post-GATE guidance we are going to provide soon, don't worry about it. And the GATE 2022, there's a Vision 2022 batch is going to start soon on Gradeup, which is from Feb 15th, and please start enrolling and take the Gradeup Super. Yes, if you have any problem in taking the subscription, please note down the number 9650052904 and you can contact anytime. We are going to help you all the time. Yes, let's begin without wasting our time. Let's begin, guys. Yes. Yesterday notes is provided already in the YouTube channel. Yes, Arafat, good afternoon. And nobody should fear, because we always have a fear. When you are facing school exams, we had a fear. When you are facing semester exams in BTech, we had a fear. But fear never stops thinking in right direction, guys. The fear always there for everyone. Remember the point. Yes, both papers should be almost in the same level. That is the reason we are providing the analysis tomorrow at 12:30, and the day depends on the paper. We are going to analyze and we are going to provide the feedback on that paper. Yes, mostly both should have the same level. If not, then definitely you will have normalization of the marks. Don't worry about it. Yes, third attempt, Durgesh. Yes, please take care of that. Yes, don't repeat the same mistakes that you have done in the past 2 attempts. Yes, those people who are attempting the first attempt, those people who are doing the first attempt, remember me, remember my words, and don't fear, because the mistakes will happen to everyone, but that mistakes don't do a lot. 1 or 2 mistakes are acceptable, but out of 65 questions, if you are doing 10 mistakes, it's gonna affect on the paper. So today at 6 p.m. I'm going to talk about how to handle that. Yes. All right, let's start. What do you learn in proportional and logic? Don't learn anything. So have you studied proportional and predict logic? Because you have the weightage 2 to 3 marks, guys. Minimum 2 to 3 marks. Even sometimes 4 marks too. Right, 2 to 3 marks only from this topic. What do you learn in the proportional logic? Look at this. And everybody should know the definitions of this connectives. Everybody, and some of the definitions are also there here apart from connectives, and you should know what is conjunction and what is disjunction. I don't need to talk about that, guys. I don't want to waste your time. I don't want to explain any point today, guys. Remember, conjunction, disjunction, negation, implication, by implication, among them this is one of the important one. And by implication, where you are going to get and help to find equivalent formulas. These two, definitely one question comes based on my analysis, because these two are going to give you a lot of definitions in the future. They will give you formula. They may ask you satisfiable. But if you are constructing truth table, it's going to affect your GATE exam. But you can construct the truth table if you have enough time. So I don't suggest to go for the truth table to do any of this point. So these things can be answered. without truth table also. If you had already concept of that without truth table, just follow them, and mostly use the logic inference. If you want to find tautology, use inference to find tautology concept. Everyone, so do not waste your time to consider the truth table. So I'm just going to give you some inputs for that. Implication. Anybody who is attempting this, remember P implies Q. Remember all the equivalences which are needed for it is nothing but assume P is true, then prove Q is true. If you are able to prove that Q is always true for every case of the P is true, then this P implies Q is gonna be valid. P implies Q is valid. This is one of the famous, this P is called as assumption, also called as premise. Q is called as conclusion, guys. Everyone, conclusion. All right. Come on, guys. Please like the session if you are watching this video, and if you forgot to like the session, please do that. And remember all the equivalences for this P implies Q. You can also say not P or Q, negation P or Q. Everybody, and you can also say negation Q, contrapositive. And remember these 3 points. It could be possible to ask direct gate question, guys. It could be asked in terms of English line or in terms of propositional statement. There are 2 kinds of logics you have. They might ask P implies Q. Look at that. The one important, because I don't teach entire discrete mathematics, only I focus on what is I'm going to predict. Look at what is possible. They might ask you if today is Sunday, I write GATE exam. Okay, maybe Saturday, that's fine, because tomorrow is Saturday. If today is Sunday, I write GATE exam. So how many ways you can speak? Assume this is a P. Assume this is Q. Here P implies Q. Suppose I want to write this is the P implies Q. And they may ask for this, what is the converse of P implies Q? Then you must be in a position to write it. That means converse of this statement. Converse of this statement. That could be possible direct gate question, guys. Where is chart? Where is chart? Please let me answer it, or you answer it. What is this? Come on, quick. Good afternoon, Jai. Good afternoon. Third year, first attempt, little bit nervous, guys. Those people who have already passed out and they are attempting first, second, third, don't nervous, Parmar. Whatever you are doing, that is for yes, your career, right? And you must have a dare to attempt everything. You might be going for placements in the future. Please don't disappoint or don't demotivate yourself. Just chill. Yes, don't panic much. This is a time to relax, and those things that you know, learn it. If not, just ignore it. Only 2 things. Those things that you know, learn it. You just follow it. Otherwise, just ignore it. And if you know it, tell me. If you don't know it, just look at it. Yes, it's a Q implies P. What is Q implies P? That means if I write GATE exam, then today is Monday. What is contrapositive? Remember these 2 important. There are many things. What is the contrapositive of P implies Q? That is not Q implies not P. That is not Q implies not P. How do you write not Q implies? If I don't write GATE exam, then today is not Sunday. Sorry, Sunday. What happens? Okay. Talk about the Sunday. And what is not Q? If I don't write GATE exam, if I'm not writing GATE exam, don't worry about English grammar, then today is not Sunday. Clear? And this is very, very important for the exam point of view. I'm not going to teach entire discrete mathematics. Remember, जो होने वाला है हो जाएगा. Don't worry about it. But जो आप कर सकते करके आ जाना बस. Yes, thank you learning mindset. Whatever. है ना? कल जो भी होगा, that is going to be the best for your life. Remember me, whatever happens, that is the best for your life. Whether you fail or succeed. If you succeed, there will be admission into IITs or PSUs, or if you fail, you might have the best future in your life. Remember that. Whether it is good or bad doesn't matter, because you are going to do always good in your life. Is that clear? Yes, contrapositive is logically equivalent to P implies Q. Yes. Correct guys. Okay. Those people who are not able to attend the live session, I'm very sorry guys, because I don't have the time to cover this discrete mathematics. Just for a few minutes. Alright. Okay, then take care of this. And by implication. How do you write it? P if and only if Q. P if and only if Q. So I can write in English, P if and only if Q. Here there are two statements guys. P if Q and P only if Q. How many of you know P if Q? How do you write P if Q? It's nothing but Q implies P and P only if Q. It means P implies Q, and this can be also written as P equivalent to Q. Alright. So please try to remember these sentences. This could be asked directly in the exam. Yes. Clear? Yeah, just I will try to make you revision on discrete mathematics. Whatever you remembered, just follow it. So I'm not going to teach anything. Yeah, inference logic, just remember the definition in case in the exam comes. Suppose there is a P and there is a Q and there is a conclusion R. So what is the meaning of this? Here there are two arguments which are PQ. There is another argument which is R. So these two are called as assumptions. You need to assume the P and Q are true. They are called as premises. Actually it is premises. You need to assume P is true, Q is true, like this. P is true and Q is true. And you have to prove R is true. Always you need to make a strategy. The given premises you need to assume true. They don't say it is true. You have to assume it. So this is called as P and Q implies R. If you try to make a truth table for that, it must be tautology. Then we say this inference is valid. This inference is valid if P and Q implies R is tautology. But it is very, time consuming if you want to prove using truth table. Just 1 hour, Fahad. Already 20 minutes is over. I mostly take 30 to 40 minutes or 50 minutes. Right, I don't take much time. I know that value of your time because I don't want to take today's session. All right. So let me quickly complete it. So inference logic you understood. Just one example guys. Suppose I have P and Q R and Q and R or S. Is this conclusion or not? Is this correct inference or not? Is this inference valid or not? I'm asking, is this valid or not? This is argument 1, argument 2 and argument 3. So I'm indirectly asking A1 and A2, is it implies A3. If this is tautology, then this inference is valid. Okay, tell me guys if you already practiced, otherwise ignore it. Come on, quick. Yes, Siddharth. Hello, how are you? And this is most predicted question in the first 1 or 2 marks, definitely comes from the first propositional logic. Valid or invalid? Quick guys. It is valid. Who is invalid? Jai Kumar. Why invalid? And are you going to prove it? Are you going to consider truth table? No. Assume this is true. Assume it is true. Assume this is also true. Can we prove this is a true? Later on we'll prove it. First assume them. If P and Q is true, it means P is equal to true, Q is equal to true. If R and Q is true, R is equal to true, Q is equal to true, then only it is true, right? If anybody is a false, the whole argument become false. Whole argument. Now by taking this, now put here values. R already known as the true. Take this and all of them put here. What do you get? True or S, which has to be true. That means this conclusion is always true because R is given as a true. R is given as a true. Then why can't you say R or S is true? Yes, that is the reason this inference is valid. So I can say that it is tautology. Otherwise I can say this inference is valid. In aptitude also this is going to help you. Remember my word, in aptitude logical deductions also this inference logic is going to help you. Remember this point, it is very important for the GATE exam. Why I am taking much time for you? Because general aptitude also you have a logical deduction. In English lands they are going to give you. Yes, Jai. All right. Now remember some of the concepts. P or not P. Is it true? Because if P is false or true, the whole propositional statement always gives a true. Yes, true. And P and not P, if one is true, other definitely false, then the result is false. And P or F, if one of the proposition statement is false, then other propositional statement only in the result if you are doing disjunction. And P and true is always P because result depends on P. If P is false, result is false. If P is true, result is true. And similarly, P are true. Now in the disjunction, true or anything is true. And all are correct. You know, some people are good at digital logic. I asked you to follow digital logic if you want it. P plus P bar, which is equal 1. P dot P bar is equal 0. If you are good at digital logic, P plus 0 is equal to P, and P dot 1 is equal to P, and P plus 1 is equal to 1. P dot 0 is equal to 0, and P plus P is equal to P, and P dot P is equal to P, and P bar is equal to P. De Morgan's law. You can also use De Morgan's laws, which are very good and which are very easy to write. But always I recommend if it is a propositional statement is very small, then use it. Yeah. Pushkar, don't worry. There is nothing to study now. And always remember what laws are important. I'll talk about which laws are important. Commutative laws, associative laws, and distributive laws, if possible De Morgan's. These 4 are important, guys. Even one of the laws is there, identity. In entire computer science, and identity laws, commutative laws, associative, distributive, De Morgan's are there in many subjects. Like in mathematics, linear algebra, and propositional logic, digital logic, even theory of computation also we have these laws. Everybody? Yeah. I hope you know all of these laws. Even compiler also you have associativity. If there is an operator, are you following left to right or right to left? So associativity laws, left to right or right to left. Right? Please try to remember them if you are already understood. Okay. And there are so many laws, just follow them later on. Now, let's move to predicate logic. Yes, let's move to predicate logic. Abdullah, why are you worried? Did I complete my class? Abdullah? Okay, thank you so much. Keep asking so that I can look at it. Predicate logic. What is important? Predict at least. That is overall I said 2 to 3. Here we can predict 1 to 2 marks definitely in the exam. Minimum 1 or 2 marks. Then how do you understand? There are quantifiers. Do not forget the definitions. Quantifiers, we have 2 things. You should know how to write them. Let me help you. Those people who are, where am I? Okay, look at, don't worry much about it. I'm assuming this is my domain. In the domain you have x1, x2, x3. I have 3 elements. Of course you can also apply for infinite elements. Assume this is your domain. If you are applying this definition for all x p of x to this domain, what is the definition of this? If you are assuming this is your definition, how do you write? P of x1 and P of x2 and P of x3. Every element of the domain, this predicate must be true. Then we say for all x P of x is true. Only when, if and only if this is true. I hope you remember this definition while you are studying. Come on, quick. Everybody. And there is one more. There exists x, P of x is true. If anybody is saying that, then what is your definition? If and only if at least one object proves that that predicate satisfies true. How do you write that? P of x1 or P of x2 or P of x3 is equal to true. And do not forget the definition, because definition only will help you to prove every formula in the exam. Right? If you are trying to remember, you will forget in the exam, no doubt. This definition is only important in entire chapter. All right. Okay, let's move to some important statements. Look at this one. You understood there are infinite elements in the domain. Then you need to apply the conjunction for all, disjunction for there exist. Okay. When somebody is speaking for all x, I can write for all x, or I can write every x, or I can say each x. And if anybody writing some x, there exists x, or I can write in English there exists x, or I can write at least one x. And remember the synonyms, because in the exam we do not know how do they explain. Yes. Okay, now look at when you have two variables. Be careful how do you write them. Right? Somebody like x likes y, or x divides y, and when you are relating the two elements or two objects in the domain, you must use the two variables. So this is for all x, for all y, P of x comma y. For all x there exists x, and know the difference between these two. Let me help you the difference. Some people may not aware of that. Let me help you. If you are not knowing that, please ignore it. Just I am going to help you one thing where people might confuse about it. For all x there exists y something, P of x comma y. What is the difference between there exists, even let me write many things. There exists x for all y, and let me write there exists y for all x, and let me write for all y there exists x. And I'm just going to use one statement to remember. Just follow that, guys. Assume P is just likes. Assume that P of x comma y. Assume that x likes y. X likes y. Then how can I talk about all of them? How can I talk about all of them? Remember guys, first one, every person likes some person. How do you write that? Here, every person or everyone likes someone. Very simple. Everyone likes someone or somebody. Everyone likes somebody, guys. That is the first one. Everyone likes somebody. And if I am assuming two people, this person likes somebody and this person likes somebody else. No need to be same person. And this one, there is a person who is liked by the everyone. Look at that. There is some person, reverse you have to speak. Someone liked by everyone. Some person liked by, because you are talking about X, everybody. And the third one, there is a person who likes everyone. Someone likes everyone. We didn't change the predicate. Look at everywhere x comma y. Only these quantifiers are going to change. This one, everybody liked by someone. Everybody liked by someone. Because y is coming first. Everyone liked by someone. Clear? Come on. I am not able to see the chart, guys. Is the chart working or not? Just say yes or no. Because in the exam, if this statements comes, interpret properly. That is my intention. All right. Just take the screenshot and revise it. Okay. Even there are other things. There exists x, there exists y, there exists x, there exists y, there exists x. And also we have other things. Remember. Okay. Now, this could be asked directly in the exam. Directly, guys. And I'm giving 3 stars for this. If you are not able to understand, at least remember. Yes, there are no doubts here. There are no doubts. Again, last one. There is no time to clear your doubt. I will cancel this class if you are asking the doubt. Don't create the doubts in the last minute. If you don't know, leave it. If you know it, follow it and revise it. This is the revision, not learning class. Yes. Alright, now look at this. A commutative asset chodo, abhi Siddharth. Right, if you know it, follow it. First one, the for all x p of x, you can apply negation. Okay, let me help you one thing before writing, guys. Let me help you. For all x, p of x you are writing. How many of you know this is same as for all x, comma, p of x. It is same as for all x, p of x. You can write many ways, guys. You can also write simply for all x, p of x. Remember, all these statements are same here. All these statements are same. Now, somebody is trying to apply. Somebody is applying for all x p of x. So what I can do is, I can apply negation twice. Because these two cancels, you will get just for all x p of x only. But how do you apply now? I don't want to cancel this. I want to keep as it is. But one I want to send inside. So how do you do that? This not, you can apply to this. Both of them. So what happens? Not for all will become always there exist. Everyone? So you get there exist. And not p of x. And this is not the same as anybody writing not for all x p of x. This is different. It's just there exists x p of x, guys. Remember this. This is different. This is different. Just remember how to apply them. Just remember how to apply them. Not when you have it. This is going to be applied to everyone because quantifier has a more precedence. So first quantifier we apply, then not we apply. How many of you know? How many of you know the precedence rules? For all there exist, then not, then and, then or, then implication, then by implication. Of course, by implication also called as equivalence. This is the precedence table, guys. This is highest precedence, this is the lowest precedence. In the exam, there will be something which is tested for you. In the exam, there will be something which will be tested. Like they don't give any appearances. Like they may ask anything. Now, do not confuse by looking at here. Even I can write something. Okay, that's enough right now. And how to do that? Even let me change it. Let me change it a little bit. Then how do you apply now? How do you apply now? You should know how to apply this because there is no parenthesis. Look at this table. Okay, I forgot to apply quantifier. Let me do that. Okay, something is here. Now, always quantifiers as highest precedence. So, try to apply first. So, we apply it. Always quantifier as highest precedence. Applied it, guys. Then look at the operators. What do you have? Not, by implication and implication. Who has more precedence? Not. So, we apply not first. And then we apply implication. So, then we apply implication. We applied implication. Then last in the final, you apply by implication. Clear, everyone? So you must be aware of how to apply these precedence rules, guys. Even you know sometimes the whole predicate logic, if you are not aware of this precedence rules, and you might fail to answer in the exam, but this is enough if you want to understand the precedence rules. Clear? Any confusion here? How to apply them? Any confusion? Please like the session, guys. Please like the session. All right. Okay. Now let's look at one by one. Of course, don't try to elaborate in detail, which takes much time. So now look at the definition of for all x is and only. So here, what is you are going to get? You are going to get and between the p and q. Like if you have two objects, p of x1 and q of x1 and p of x2 and q of x2. And they are also going to get same, but p of x1 and p of x2, q of x1 and q of x2 is one side, that's all. And these are going to be same when you apply the definition. Don't apply anything. Just apply the definition. If you apply the definition, p of x1 and q of x1, and again x2, p of x2 and q of x2, in between and is there because of definition of for all. And here you are saying that this and that, so you can combine these two together and these two together, you get the definition. Do you agree that the first equivalent, that is first equivalence is valid? Everybody, you don't need anything, just a definition for all, just a definition for all. Everybody, if you want to prove, I can prove it, but not required. I feel that you can understand. Right? Everybody understand? I didn't do anything, just I applied the definition of for all. And similarly, apply the definition of there exist. Why these two are true? Because definition says that, for this definition says that p of x1, I am applying for only two objects, or q of x1, and this one when I apply for x1, or when I apply for x2, or p of x2 or q of x2. And the same thing, you can prove it because these two I can write together and these two I can write together, and you will get exactly same again. So both sides you are actually speaking the same. Only Only all the predicates of P, all the predicates P you are bringing one side here, all the predicates Q you are bringing one side. Everybody? Alright, come on, quick. Just the definition you are applying for first two, but here onwards you need to be very careful. These are not gonna be easy. Right, even it might take even 10 to 15 minutes, so just follow them, and they are not equivalent, but one direction holds. Every x p is true or every x q is true, definitely I can prove that every x p or q is true. This side holds, but other side need not be true. Everybody agree? Either this is true or this is true, I can always prove this statement is true. Again, you can apply definition if you want it. And similarly, there exists x, both are true. When you go that side, that implies there exists x p is true or there exists x q is true. Definitely happens. Like you have many other equivalences. Don't worry all of them, guys. In the last minute, you can't revise all of them just by looking at in one slide. Okay, I'm just ignoring, just practice them. Okay. That is about proportion and predicate. Now let me help you one thing. Okay, what is important for GATE? Okay, I have only one statement always: every student is clever. And some student is clever. Please try to write the predicate logic for this, and mostly these are going to be your GATE exam questions. Model. And every boy and girl is clever. And if you want to apply not, you can apply yourself. Keep answering. What are the predicate? Why I am forcing on proportional predicate logic? Because at least this session can bring you 1 or 2 marks in the exam. That is the reason I am forcing on predicate logic, guys, because definitely guaranteed one question from predicate logic, and that must be from this slide. I predict maybe the words might change, but the logic will be similar. Yes, come on, guys. Okay, how do you write this? For all x, s of x implies c of x. In the exam, they might write even for all x, comma, means comma has lowest precedence than anyone. If you want to look at, the comma is the lowest precedence than anyone. Remember that, comma. And I can simply write s of x implies c of x. This is fine. Exactly. Right? Every always correspond to implies. This is implies. But when it comes to sum, the is implies and here. Is nothing but and here. So how do you write? There exists x, s of x and c of x. Right, next one, every boy and girl. Okay, let me look at it. What is your answer? This is one mistake people might do. I know it. Boy and girl. In English, it's fine. But in propositional, the object never be both simultaneously. Yes, that's good. Who is that? Abhishek is right. In propositional, you can't use the and. What do you have to use? For all x, the boy and girl means you have to write are, because object never be both, either boy or girl. Is means implication because of quantifier for all, and clever, C of x. So keep that point. And in English, in proposition, we can't write and. We should write or, because object never be both boy and girl. In predicate logic, you can't use and because of English word. In English and, but in propositional statement, it should be or. So remember that point always. Some things are going to change when you write as it is. Okay, here some boy and girl is clever. So similarly, there exists x, some boy and girl. So how do you write now? B of x or C of x implies C of x. There is, English sentence problem. I can ask some boy or girl is clever. Right, everybody, some boy or girl is clever. Because of some, I have to interpret properly this sentence. Okay, every student is clever. This time, every student is clever and intelligent. That and is and only, because you need to satisfy both of them. Now don't make this and is or. So every student, that is for all x, S of x. Now, sorry, some means and, right? I'm very sorry, because sometimes I do mistakes because of I'm not explaining some things. It is and every student is clever. That is implies clever and intelligent. That is C of x and intelligent. So now you need to write and only, because you need to satisfy both the properties. This time there exists, you write, and S of x is means and you need to satisfy C of x and I of x. You need to satisfy all of them, guys. All right. So don't worry much, but here the most of the complicated predicate statements are solved here, most of them. Yes, but do not argue. Even I do mistake. Just blindly follow them, whatever you understand. Okay. So next there is one more point, which is about not. Not every student is clever. This is one statement which is very popular, and another one, no one is clever. Directly I am writing. No one is clever, or none of the students is clever. So how do you write the predicate statement for both of them? Yes, if you are able to write these two, then it's enough. In the predicate logic, you are understood all the statements, how to write. These two are very, very important now. See, that is none, that is not. This is no one or none of the students is clever. None of the students is clever or are clever. Okay, just let's write it. Here what you do is not just apply to the whole statement as it is. Not here, and every student is clever, you apply here. That means for all x, S of x implies C of x. That's it. Now you can write as you want it. You can apply not as you want it. Not for all, there exists x. And you can apply not to this statement also. And implication you can write as, already there is a logic, P implies Q, nothing but not P or Q. You can apply that too. What is that? There exists x. Before this, not application. Not S of x or C of x. And remember, it's very simple. Only you need to apply carefully. Implication you need to simplify first. Now apply not. Not is S of x and not or is and not C of x. Yes, that's all. And this one, no one is clever. How do you apply? This no is you apply not, and no one is clever. That one you have to say some. Someone is clever. Here some is not visible, but no one makes not someone is clever. What happens? There exists x, someone is clever. Means, let's say some student, S of x and C of x. Someone is clever. Now apply the not. Not there exists, which will become for all, and not S of x. Not of and is or, and not C of x. That you can convert to implication also. Not x, not P or Q form. S of x implies not C of x. That means every student is not clever. No one is clever means every student is not clever in English line. But do not try to convert in English, because that's going to be complicated. So convert in proposition, that makes easy. Right, everybody clear? And these questions are very popular in the exam. So I hope this session I have mainly focused on propositional predicate, but I'm going to help you what is important for the remaining topics. Okay, let me conclude very quickly. Okay, anything if you don't understand, just ignore. Yes, in set theory, please focus on the types of sets, and in this subset, power set are very important, guys. Subset and power set, the main relation between them, let's say capital A is a set. I can say X is a subset of A if and only if X belongs to power set of A. And this is one of the important point in this. Everybody? Okay, Rakshita. Yes, Nagpal, if any confusion is there, just ignore. You cannot learn if you have any confusion. Remember that. Those people who are confusing anything, ignore, because you might be studied so many concepts that's gonna help you in the exam. Right. If I'm going to teach implication by implication, can I do the revision? Right. All right. So remember this point from subset and power set. Any set which is a subset of power, any subset of A, that's definitely there in the power set of A. Everybody? Yes, one small example, those people who are not able to conclude that. Example, suppose I have A is equal to 1, 2 and write all the subsets. You will have empty set, you will have a 1, you will have a 2 and you will have 1, 2. This is like x1, x2, x3, x4. Now look at the power set of A. Power set of A nothing but you will have x1, definitely x2, x3 and x4. What do you have here? Look at that. Any set is a subset. Xi is actually subset of A if and only if that Xi must be appears in power set of A. That is what I am talking about, which is possible to be appeared in the exam directly, but very easy. Clear? Everybody? Just I am giving you possibilities. I really do not know what is going to happen in the exam, but possibility, power set, subset is very important, very. And some important points too, like if you have A1 union A2 union is equal, let's say A. If I say if A is infinite or simply A is infinite, what can you guarantee? If and only if the result is infinite, what can you talk about this one? This was a previous year GATE question. At least one of AI must be infinite. then only result is possible. Assume there are only n sets we have here. N is a constant. Everybody, this was the previous year gate question. Now what I am predicting in the coming gate questions, coming years, A1 intersection A2 intersection A3 intersection AN is equal to A. If suppose I say A is infinite, if and only if, what can you guarantee? Very interesting. Don't ask finite. I can't answer about finite, but I can ask about infinite. This time, if the result is infinite, it indirectly says everybody is infinite. Every AI is infinite. Then only you can get the common set is infinite. Everybody, all should be infinite. Yes, this is going to be the coming gate question if they want to frame on this intersection and infinite relationship, guys. Previous gate question was union and this is intersection. Clear? And just to apply and interpret properly, because it can be answered easily. Only you need to think about. Okay, some of the properties, you can easily understand, like, universal set and empty set, and A union A complement is universal set. These are very basic properties, guys. Even TOC also we have studied many times. It's a commutative property, intersection, union, commutative property, associative property, I think distributive property. So these properties are very, very important. All properties are satisfied here. And learn about union, intersection, complement wherever you go. In TOC, without this, TOC never, you will never understand it. Yes or no? Yes, we are going to start 2022 batch. Yes, Rakshita, Feb 15th, we are going to start the batch. And you have already a mobile number, you can contact the Gradeup, they will be helping you, right? All right. Set operations. Okay, now in this we have a very important relation between this 5, and remember this one, n is a set of natural numbers. Here the relation is n is strictly subset of z, and this is strictly subset of set of rational numbers, and R and complex set. And it's a very, very important relation. In group theory, this is going to help you a lot. In group theory, this is going to help you a lot. The reason is, if n is closed for plus, then everybody will be closed for plus. Suppose q is closed for multiplication, then everybody closed for multiplication. So there is a one beautiful relation between all these 5 sets, guys. All right. Mahalakshmi, whatever I can do, I am trying to do here, right? पहले ये खत्म करने दो यार, होगा तो करेंगे. Relations. Okay, in the set theory, the second important topic is relations. Learn about every definition. Like I'm writing it, but I can't explain all of them now. Relation is nothing but, if you are saying R is a relation from A to B, both are non-empty sets. R is a relation from A to B if and only if R is the subset of A cross B. If anybody asks number of relations, of course I have written number of relations later on. This is the definition. Identity relation. And for all of them we are going to do relation on A. R is identity relation on A, because we are going to do from A to A now. From A to B we don't do, from A to A, because we are going to apply on binary relation or square matrices, guys. R is identity relation on A if and only if you have x comma x such that x belongs to A. For all x belongs to A, this is going to be there. Everybody, for all x belongs to A, x comma x in the relation, and only diagonals. And reflexive, for all x belongs to A, x comma x belongs to R, and others may or may not present. That is your choice. Come on, quick. Everybody, just I am helping you to remember the definition, guys. What is the irreflexive relation? What is the irreflexive relation? Irreflexive is for all x belongs to A and x comma x should not be there. What is symmetric relation? What is symmetric relation? Yes, all the best everyone, and please compete with friendly environment, and don't worry if other people are doing well at good attempt, and you should also try good attempt. If anybody is answering every question, don't worry about others, guys. And symmetric relation. What is symmetric? If x comma y belongs to R, then y comma x belongs to R. And what is asymmetric? If x comma y belongs to R, and this should not be in R. And what is antisymmetric? Except diagonal, so you apply this definition. What is transitive? If A comma B is there, B comma C is there, then A comma C should be there. Equivalence, you must satisfy reflexive, symmetric and transitive. And what is partial? It is reflexive, antisymmetric and transitive. I want you to remember these definitions, because without definitions we cannot answer any question which is based on this. All right. Yes, if anybody want total number of relations, just remember them if you can. Without understanding the concept, I can't help you to remember all these formulas. Number of relations from A to B, 2 power mn is also called as, remember my concept, 2 power A into B. That is the best technique. From A to B, just say 2 power A into B. And if I ask number of binary relations, previous gate question, number of relations on A, binary relations on A, which is nothing but 2 power A into A, which is equal to 2 power A square. 2 power A square, guys. Assuming A has m elements, B has n elements, 2 power mn. Don't try to remember mn and m because you confuse a lot. And this one, number of reflexive relations, you can use n because they are all just having n elements in A. There is no capital B here. So it's fine. You can remember these formulas. 2 power n square minus n is a good choice, because out of n square, in the n square elements in the matrix, just delete the diagonals because they are always present. They are always present. There is one more. Number of irreflexive also same. It is also same. It is also same, guys. If you have studied already this, these two are having same number of relations, even though they are different relations. And symmetric relations, you can, of course, I can't help you now. Looks like this is it's a different formula, 2 power n, because our diagonals may or may not present. 2 power n square minus n by 2. If you do the summation, you will get 2 power n into n plus 1 by 2, guys. That's the best way to remember. Diagonals have 2 choices and non-diagonal symmetric combinations have 2 choices. Okay. Those people who knows the concept, they can remember this way. And another one is similar. 2 power n, diagonal elements, we don't apply the symmetric asymmetric condition. And 3 power n square minus n by 2. This many symmetric combinations are there. And symmetric asymmetric is very simple. And irreflexive already written below, so that's same exactly. It's there already, fine. So if anybody studied them, Himalaya, DCFL अभी चाहिए क्या? It is decidable. Himalaya. यार ये TOC क्वेश्चन आके डिस्क्रीट मैथमेटिक्स से पूछ रहा है. Frustrated. Okay, those people who have studied, please remember, otherwise ignore. Only best solution for me, but I always ask you to follow the definitions. And have you remembered all the definitions? Function. What is a function? If f is a function from A to B, if and only if f is a subset of A cross B, and you need to satisfy existence of mapping, and every mapping should be uniqueness. So if all the three satisfies, then we say that is a function. Okay. All right. What is a constant function? For all a belongs to a, f of a is just b. There exists one b only. This is a unique one b. There exists b here. You can simply say f is equal to b. What is identity function? For all a belongs to a, f of a is equal to a. Because here capital A and capital B must be same. Here actually f is from a to a. And injective. Every two elements of domain. Remember just one line. Every two elements of domain have distinct mappings or distinct images in codomain. And what is surjective? Every element of codomain, very simple, every element of codomain has at least one pre-image. In English, I am trying to write bijective will satisfy both injective and surjective. Yes. Everyone, just try to complete these definitions. Yeah, composition you can apply. Okay, if you have already studied, please try to remember these formulas which could be asked directly in the exam or which could be asked for particular example. You can directly apply the formula. The number of functions from A to B, you can simply remember this is a codomain power domain. Codomain power domain. That is the best way to remember. That is the best way to remember, because some people they confuse n will be here, m will be here, then formula might change. So do not remember n power m power n. Remember codomain power domain size. Alright. Himalaya, I'm not teaching everything. Just in the flow, in the beginning, I'm trying to help you how to remember it. But I'm not going to teach graph theory, combinatorics, even these topics also. And one-to-one functions, you can simply write the n is BPA. A number of onto functions, you can also use a similar formula, but this is a different one. If you have already remembered this, just follow it. But you can't prove in the exam. Either you remember before the exam by understanding, or for the particular example you can prove it. Yes, number of conditions, number of bijective functions is just n factorial, because a and b will be having the same size if they are finite. If they are infinite, you can't compute the sizes, guys. Okay. There might be a problem in number of onto functions, which might take much time to understand. Alright. मोहित कृष्णा, कहाँ से दुनिया में यार? या क्या शादी में जा रहा है क्या? स्वीट खा के जाने के लिए? मोहित कृष्णा, स्वीट खा के एग्जाम में जाएगा यार. चलो आपका मर्जी है, जो भी खाना है खा के जाओ यार. एग्जाम के पहले खा लो, बाद में भी खा लो यार. एग्जाम से पहले एग्जाम जा रहा है, एग्जाम के बाद जो रिजल्ट बैड और गुड. Okay, so in group theory, do not forget these concepts. Closure. You need to understand the closed. What is closure definition, guys? Let's say algebraic structure. Let's say X is algebraic structure, and you are applying, let's say, circle. Then what is closure? For all A comma B belongs to X, you are going to have A circle B is also belongs to X. If you are having this, then it is closed. For all AB belongs to X, if you are able to satisfy that AB, when you apply, you are going to get it, the element in the same domain, then we say closed. Otherwise, we say not closed, guys. Semi-group, it must be closed. This is a closed definition. X comma circle is a closed. Semigroup means it must satisfy closure and associative. Associative definition, I hope you know it. And monoid, nothing but semigroup should be satisfied. Additionally, identity should exist. And group, nothing but it should be monoid, and additionally inverse for every element should exist. And abelian group, it should be group, but it should satisfy commutative also. And subgroup, if you are saying subgroup S of G, of group G, then S is subset of G, first point. Second, S is also a group. Yeah, so this is a subgroup definition, guys. Yes, afternoon, Raja Babu. If you have studied, please recall them quickly. And in lattice theory, of course, if you want to study coset, all other things, factors, whatever it is, there are so many concepts are there in the group theory. Yeah. Now in lattice theory, what are the definitions you have? Poset, partially ordered set, that is Asser diagram. You need to learn about Asser diagram. And as I said, I don't want to take more than 1 hour. So let me recall, learn about the lattice. Identifying the lattice is difficult, but identifying the not lattice is very easy, guys. Lattice means every two elements in poset have meet and join. Meet and join. That's a very simple definition. What is chain? All elements of the lattice are linearly ordered. Like something like this. Like 1, 2, 3, 4. This is called as chain. And finite lattice. Chain lattice are linearly, totally ordered. Okay, finite lattice, it is a lattice with finite elements. At least remember this line, guys. An infinite lattice means a lattice with infinite elements. Yes, I can have infinite elements also. Example, n natural numbers with less than or equal to, or natural numbers with greater than or equal to, and such posets will form infinite lattices, guys. Bounded lattice, a lattice which has lower bound and upper bound. A lattice with lower bound and upper bound. Entire lattice, if you have lower bound, upper bound, that lattice is called as bounded lattice. Yes, if you want example, just one example. Don't waste our time here. One example. Somebody has given, let's say, which one you want? 1, 2, 3, 4, 5. $60. And I want to do using a division relationship. And x comma y belongs to R if x divides y. Right, this is the relation they have given to you. Then how do you draw the Asser diagram? They may ask how many edges if you draw an Asser diagram. Yes, Naman. Chain is also called as totally ordered set, linearly ordered set. Yes. Yes, everybody, please recall. If you know it, please keep on answering. Don't sit idle. Don't sit idle, guys. Okay, so how do you do that? Asser diagram, you will start with 1 because 1 can divide everyone. Yes, 1 has a relationship with everyone. Next, 2 is having a relation with 1 because 1 can divide 2. And 3 has no relation with the 2, so I can keep a 3 here because but 1 can divide 3. And 4 I can't keep here. because 4 is forming a transitive property with 2. So 4 you can't write directly, you can't connect, because 1 divides 2, 2 divides 4. And 5 I have to keep here because no relation between 2, 3, 4, 5 at all. So directly 1 I can connect. And 60 I can keep above because 4 has a relationship with the 60. Do you have it? Just check it. Yes, 4 15 is right. Now 2 can divide 4. And 3 5 has no relation, but 4 has a relation with the 60. 3 60 and 5 60. Everybody? Yes, this is a answer diagram, and also this is a lattice. This is answer diagram. How many edges? If I ask, 1 2 3 4 5 6 7, 7 edges. That could be possible gate question. And which lattice is this? Because there are so many types of lattices, guys. Is it chain? No, it's not a chain. It's not totally ordered. Is it finite lattice? Yes, it is finite lattice. Of course, not infinite. And is it bounded? Yes. This lattice, this is called as lower bound. This is called as upper bound. It is a lattice. Remember that it is a lattice first, because every two elements you have lower bound and upper bound. So what is that? Meet and join. And this is bounded lattice because you have the bound for entire lattice. And if you remembered, if every element has a complement, then we call it as a complemented lattice. Did you remember complement? Yes. How do you compute the, let's say one complement is 60 and 60 complement is 1. If you do meet and join, they must go to lower bound, upper bound, not anybody else. Don't say meet and join exists. Say that their join is 60, their meet is 1. Now look at 2. 2 complement is 3, 2 complement is 5. So I can say 2 complement is 3 and also 5. 3 complement is 2 and 5. Both happens. If you don't know how to compute, please practice it. And if you want, I can help you. 5 complement is 2 and oh. Now look at 3 complement 2, 5, 1 more, 4 is there. 4 is there, guys, because 4 also gets same answer. I'm missing that. 3 complement, it can be 2, it can be 4, it can be 5, because 3 and 4, their join is a 60, their meet is a 1. Similarly 2 also. Yes, 5 complement 3, 2, 4. That means every element has at least one complement is called as a complemented lattice. But it is not distributed, because distributive lattice, if the complement exists, it must be unique, but these are not having unique complements, so it is not distributive lattice. What is distributive lattice? Every element should have at most one complement, at most one. Everybody? Complement says at least one, distributive says at most one, either 0 or 1. Now, distributive Boolean lattice, it is not a Boolean, because complement and distributive both satisfied, then it is Boolean, but it is not a Boolean lattice. Yes. Okay, this is about lattice theory. Yeah. Now, based on the time and based on the feedback, because you are having so many things now, graph theory, all these things I'm leaving to you. But I can't waste your time. I know how much time, you are worried about exam now. Every minute is going to be valuable, guys. So I'm going to finish up very early. Yeah.
Hello students. Gradeup is happy to announce the February Mela, जहां आपको मिलेगा मौका to win attractive prizes worth ₹50 lakhs on the purchase of Gradeup Super. आज ही Gradeup Super के साथ अपनी exam preparation शुरू करें with live interactive courses and mock tests designed by the best faculty and experts, 24/7 doubt resolution and best study material. इसके साथ ही पाएं exciting prizes जीतने का मौका। तो फिर देर किस बात की? आज ही Gradeup Super को सब्सक्राइब करें।
Okay. you also have other benefits in February. If you are going to take the subscription as the Gradeup Super, you have double validity. So this double dhamaka don't lose if you want to prepare using Gradeup app. So let's come to the graph theory, guys. Okay, let's come to the graph theory. Have you understood all of this? Adjacency of vertices and adjacency of edges, right? If two vertices are adjacent, they have the common edge. The same edge is connecting two vertices, then you can say two vertices are adjacent. The edges are adjacent if two edges are connected with the same vertex. Common vertex exists for the two edges, then two edges are adjacent. So I can design the matrix for vertices and also for edges. So you can represent a graph using adjacency matrix. Remember, types of graphs, you have so many types of graphs, directed, undirected. Please remember all of them. Types of graphs, you have many, like directed or undirected. That's easy. But cyclic, acyclic, and connected, disconnected. And you should know definition of everything, because you do not know what do they ask in the exam. And mostly you talk about simple graph. They may not talk about pseudo or multigraphs. And what else we have? Planar, non-planar. But there are so many types of graphs are there in the graph theory. Yes, at least you should understand the definition of them, and especially component, very important here when you are going to talk about connectivity. What is component? It is a subgraph of given graph which is maximally connected. If it is connected graph already, then only one component exists. If it is disconnected, you will have more than one component. You will have more than one component, guys. And the sum of degrees is going to help you for many gate questions, and also going to be asked again and again. And in this, any graph, the sum of the degrees of vertices is equal twice the edges. Not only that, if you are going for planar graph, even sum of the degrees of regions also will be twice the edges. This is for any graph. This is for any graph, but this is for planar graph where you have a regions. And using this, there are so many formulas in the graph theory. So many formulas in the graph theory. Remember that. So many formulas. Assume E represent number of edges. If you know that, if minimum degree is a delta, and assume that n vertices are there, then the relation is going to be like n into delta definitely is going to be less than or equal to twice the edges. If you have the maximum degree in the graph, if you know that there is a maximum degree, you know the maximum degree of the graph is delta, then that n into delta definitely greater than or equal to twice the edges. If you are going to make the relation between these two, what's going to be happening? This is less than or equal to E, this is greater than or equal to E. So what's going to happen? You can remember this, that n into delta less than or equal to E less than or equal to n into delta. You can also write E less than or equal to n delta by 2, and here n del by 2. And these relations might help you in sometimes, so you may use it. And there are many points. At least two vertices in the graph should have the same degree. Exactly. Yes. And what are other points could be asked directly in the exam? If the sum of the degrees is even, 2e is nothing but even. Here there are two things are there. There are two kinds. How many even degree vertices? In graph, how many odd degree vertices? To get the result is even. Very famous question in the exams. How many odd degree vertices? This can be any. Even degree we don't have any problem, but this must be even to generate the result is even, guys. This is the most important question for exam. Asked many times, so may or may not happen in future again. Yes. And also one more note. Any graph you take, simple graph, at least 2 vertices must contain same degree in the graph. It is very, very important in degrees. In degrees, it is very, very important, guys. Yes. So do not forget about it. And I just want to close the session because I don't want to disturb much, but I will revise whatever is needed. Yeah. But I'm just going to speak, path graph. It looks like this is a path graph. Star graph, you will have a center point and remaining all are singleton vertices which has 1 degree, and tree basically a graph without a cycle. And very, very important again, tree definition, very, very important, guys. Don't ignore the tree definition. Tree and rooted tree both are different. Rooted tree is used in applications basically, and tree is just a graph we call a graph without a cycle. That's fine, but that is a connected, or you can say minimally connected graph. Where you will have n minus 1 edges, no doubt. N minus 1 edges. Okay, there are many definitions for for tree, and understand tree rooted tree difference. Rooted tree basically we use in data structures where root is there and remaining will have a relationship, parent child relationship between the nodes or elements. Yes, like in data structures, I'll go wherever you want to use. And what is the difference between tree and rooted tree? Rooted tree has different properties, guys. A rooted tree has many properties, like you will have a depth, and you will have height, you will have levels. There are many interesting points are going to come. Even you are going to get leaf and non-leaf nodes, and the word root is different here. The root is not exist in general tree. Yes, if not connected. Yes, there is one more word, forest. Sorry, guys. There is a different one, forest. Forest is like, we have a single graph. We have a single graph. Assume this is a complete, okay, sorry. Look at this one. How many components are there? This is called as a forest. This entire thing, is it connected or disconnected? This entire thing, assume A, B, C, D, E, F, G, H, I. Is it connected or disconnected? This graph is disconnected graph. How many components are there? 1, 2, 3, 4. 4 components. Is that each component is a tree? If each component is a tree, then we can call that graph is a forest. What is the forest definition, guys? If each component is a tree, then that graph is called as a forest. Everybody? Yes, tree has n minus 1 edges, but forest has n minus k edges, where k is the components and n is the number of vertices, guys. Everybody? All right. Okay, if you know, just repeat it. Cycle graph, where you have many properties for cycle graph. The cycle graph, you know, yeah, just let me explain all of them in one slide. Cycle and regular graph and complete graph. You know, you have C3 and C4, C5. It's very easy to understand what is this graph, and all the vertices forms a single cycle. All the vertices forms a single cycle. Yes, regular. Okay, here look at, cycle is always connected, but regular can be connected or disconnected, guys. Don't assume it is connected. This is a very special graph in the world. Even look at, this is a regular graph. Every vertex has a degree 0. This is a regular graph. And look at this, even it is disconnected, but every vertex has a degree 1. This is also regular. Understand, regular graph, no need to be connected. Even I have cycle. Every vertex has the degree 2, so this is also regular graph. Yes, regular graph need not be connected. Remember that point. Remember that point. Yeah. And complete graph, you know, a graph which has maximum edges, n into n minus 1 by 2 edges. Any graph which has, any simple graph which has n into n minus 1 by 2 edges, then that graph is complete, or every 2 vertices are adjacent. You can also write it, every 2 vertices are adjacent in this graph. If any graph which has every 2 vertices are adjacent, then that graph is called as a complete graph. Or you can say, in a simple graph you have n into n minus 1 by 2, that is nc2. nc2 edges are there. Yes. Cycle graph is, yes, is always a regular graph. Don't say subset, yaar. Graph, we don't say subset, we say is. Okay, set of cycle graphs is a subset of set of regular graphs. So please careful, use the is and subset, both are different here. I can say every cycle graph, every Cn is regular graph. Even every Kn, that is a complete graph. Here I can say every vertex, another definition, guys, every vertex has a degree n minus 1. This is another definition. There are 3 definitions I have given for a complete graph. Right, this is any simple graph in here. Every Kn is also regular, but regular need not be complete, regular need not be cycle, regular need not be connected. So all these points are important for the exam. Yes, in regular graph, all vertices must be same. All vertices should have same degree. Contain same degree. Like 2, 2, 2, 2 or 1, 1, 1, 1 or 0, 0, 0. In degree 2, there are so many graphs. Degree 1 also so many graphs, guys. Assume degree 2, this all are degree 2 only. So many graphs, this all are degree 2 regular graphs. All the cycle graphs are degree 2 regular graphs. Alright. So I don't want to waste your time, guys. I want to close this session as soon as possible. Bipartite graph. Bipartite graph. And I don't know how many, exact definition of bipartite. Let me tell you. And it doesn't look like bipartite. Look at this. How many vertices you have? I can say this is a bipartite. I don't know how do you know it. I can keep V1, V2 together. It's a one set and V3 other set. Even though I don't have edge, it's fine. Still it is bipartite graph. What is a bipartite graph definition? If the set of vertices, you are able to make two independent sets. This is a one independent set, but I can make all of them in one, but I don't want one, I want two. This is one independent set V1 and this is another independent set V2. If any graph can be divided into or vertices of any graph, okay, that you can understand. Vertices of any graph can be divided into, if vertices of any graph can be divided into two independent sets, then that graph definitely bipartite graph. And every bipartite graph, 2 is not a chromatic number. Wrong. I can keep 1. It is 2 colorable is different, 2 chromatic number is different. Remember, every bipartite graph is 2 colorable. It's not a 2 chromatic number. Remember, every bipartite graph, very careful when you use these words. Bipartite graph is no need to be connected, even disconnected also. This is chromatic number is 1, guys. You can color every vertex with the same color because there is no adjacency. Every bipartite graph is 2 colorable. But chromatic number of the bipartite graph, like G of M comma N, is less than or equal to 2. Both are different words. We can always color with 2, but at most 2 is the best word. Yes. But also you can make one independent set. I don't make it because I want bipartite. So I can call this bipartite, I can call this disconnected graph. So it's 2 colorable. At most 2 colors. When you find out chromatic number is at most 2. At most 2. Alright. But if it is connected, then chromatic number exactly 2. Every connected bipartite graph, connected definitely. Connected bipartite graph where you have n greater than or equal to, then that is chromatic number is equal to. That's different. Right. Connected bipartite graph, definitely chromatic number has to be exactly 2 because you will have at least one edge. I'm assuming at least one edge. Remember that. Unconnected, right? Then definitely you need at least 2 colors. Yeah, please revise them. Yeah, I'm going to please cover them because this takes at least 1 hour to explain. I'm not explaining anything, but I'll speak. If you know it, revise. Cut vertex. There is a vertex in the graph. If you delete that, the graph will be disconnected. Yes or no? A simple example. If I have this graph and this is a cut vertex and this is also cut vertex. This B and C are called as cut vertices. And bridge, there are 3 bridges. Every edge is a bridge because it is a tree already. In tree, every edge is a bridge. And these are very important questions for the exam, guys. Cut vertex and bridge. Let me take one simple graph to understand because it's already model gate question. How many cut vertices are there in this graph? Find out quickly. If this comes in the exam, you will be saved. If this comes in the exam, you will be saved, guys, because it is a very, very important question for the exam point of view. Finding how many cut vertices, finding the bridges. How many bridges, how many cut vertices? Come on, quick. How many cut vertices and how many bridges here? I'm very sorry, that is 1 day before I'm taking the class. This could have been taken 2 days, 3 days before, but I'm very sorry for that. I want to close this session as soon as possible. Within 5 minutes, I may close it. Two cut vertices. Which are cut vertices? This is, when I delete this, the A will be separated from there. And when you delete this, and F, G are separated from this. But if you try to delete only A, remaining still connected, D remaining still connected, C remaining still connected. So B and E are cut vertices. So 2 cut vertices. also called as articulation points. How many bridges are there? How many bridges are there? Let me number it. 1, 2, 3, 4, 5, 6, 7. Find out which are bridges. Here we got B and E are cut vertices. Find bridges. Who are bridges? 1 is the bridge, because if I delete this, A will be separated. Who else? 6 is the bridge, because F will be separated. 7 is the bridge. So there are 3 bridges. 1, 6, 7 are bridges. There are 3 bridges. Seven, 3, 1, 6, 7, 3. 3 if you delete, still it is connected, right? Why 3 is the bridge? Who is that? Naman? Okay, answer is 3. Oh, sorry. Answer is 3. Okay, I got it. Okay, I was thinking about the 3 edge, the edge 3 is bridge. That's wrong. All right, correct. And I am giving 3 star for this because it is expected in the exam. It is expected in the exam, guys. Okay, please study cut set. There are 2 types of cut sets: vertex cut set and edge cut set. Instead of deleting one vertex, set of vertices whose deletion the graph will be disconnected. Set of edges whose deletion the graph will be disconnected. Okay, cut set, please study yourself. And independent set and covering set. Very important relation I am going to give. Please remember that. Independent set and covering set. And remember this, vertex independent number plus vertex covering number will give you the number of vertices in the graph. And there is another relation, edge independent number plus edge covering number. If you don't know the definition of covering and independent, please don't study at all. Number of vertices. And please remember these formulas, which will help you a lot in the exam. Everybody, vertex independent number and vertex covering number, if you add them, you will get the number of vertices. I'll give one example to find out, but be careful. If you don't know the definition, ignore it. Okay, look at this example. Okay, I want to find out what is vertex independent number. How do you get that? It's nothing but size of largest vertex independent set. You need to find out the largest one. You need to find out the largest one. Can you find out the largest one? Largest, remember. Try for the largest. Don't try for the smallest. A I can keep, D I can keep, E I can keep. 3 vertices I can keep max. Can I keep 4 vertices? Is it possible? Is it possible? Not possible. Right? This is the largest one. Sometimes more than one largest possible, guys. Sometimes. Please like the session. If you have not liked it, guys, please like the session. Please. Yes, I can see 275. We need to move 300, guys. Please like the session, guys. And also install the Gradeup if you have not installed the Gradeup app, which is going to help you if you are preparing for GATE 2022. And you need the post-GATE guidance after the exam, and Gradeup is there for you to give the post-GATE guidance. So vertex independent number is a 3. And what about vertex covering number? And now covering, vertex covering. Okay, let me delete this, it will confuse you a lot. Now you need to take the minimum vertices so that all the edges are covered. I'm trying to take something like, if I take minimum, right? If I take A, B, C, D, everybody is covered. But if I take a B, this edge is covered, this edge is covered, and this edge is covered. And if I take a C, then this edge is covered, this edge is covered, and even this edge is already covered by B. B comma C. If I take B comma C, every edge is connected to at least one vertex of this. everybody? B comma C. If I take B comma C, look at every edge. Every edge of the graph, is connected to at least one vertex of this set. Is it correct? Every edge of the graph is connected to at least one vertex. You ask me any edge here. Ask me 1, 2, 3, 4, 5, 6. 1 connected to C, 2 connected to B, 3 connected to both, it's fine. 4 connected to C, 5 connected to B, 6 connected to B. Every edge of the graph is connected to at least one vertex. Is called as vertex covering. And very simple, I can keep all of them. This is also vertex covering, but this is a trivial, but this is minimal, or smallest. I can say smallest. If I delete anybody, some of the edges are missing to connect with vertex. Yes, this is smallest vertex covering set. Now, what is vertex covering number? Smallest, size of smallest vertex covering set, that is equal to 2. And if you add 3 plus 2, did you get the total number of vertices? That is what I am talking about. 3 plus 2 is equal to 5. 3 plus 2 is equal to 5. Did you get that? 5 is the number of vertices of the graph. Yes, everybody clear? Similarly, you can try for edge covering set and also edge independent set and find out them accordingly. You will get the similar answer. Just I am trying to help you how to calculate it. Okay. If you have not studied, please avoid it. And similarly, you have a matching of a graph. Matching is one of the important topic which was asked 2 times already. Even we practiced in the previous day also. Perfect matching. Right, we have practiced this. And know about the matching. Matching nothing but it is a subgraph of given graph. Where every vertex has at least 1 degree. Means every vertex is connected to at least one edge. The matching of a graph. Okay, graph coloring, you know it. Every 2 adjacent vertices should have different color. The graph coloring definition is every 2 adjacent vertices should have a different color. So there are so many formulas. Please try to learn accordingly. I don't want to waste my time and your time. And please study planar graph coloring. I told graph isomorphism is very, very important. Please study it. I'm not able to explain now, but I'll just give a definition. G1 and G2 are isomorphic. This is the definition. If and only if the vertices of G1, vertices of G2 have the bijective mapping. This is the actual definition. But note, the size of vertices of G1, the number of vertices of G1 is always same as this one. Not only that, the size of G1, number of edges is also same, and every property of G1 is preserved in G2 also if and only if. Even every property of G2 is also preserved in G1. If this is connected, that is also connected. If G1 is planar, G2 is planar. If G2 is not planar, G1 is not planar. Yes. Everyone? Yeah, please also study Euler graph and Hamiltonian graph accordingly. If you have a question, I am not going to answer. That is straightforward. Alright. Please don't pose your questions today unnecessarily. Arpit, what are you doing? Okay. So also learn line graph, click and strongly connected component. I can give you, these are not easy questions, but practice them, which are very effective, because a line graph click, I didn't expect that, but which was asked before few years, and strongly connected component also once it was asked. Yes, if you have a question, please go and open the notebook and answer it yourself. And I'm going to close soon. And in the combination, please learn what is the sum rule, because there are so many problems in aptitude also, they depend on sum rule and product rule and principle of inclusion and exclusion in the Venn diagram, and permutations with repetition, without repetition, combinations with repetition, without repetition, and binomial theorem to find the coefficients is very important, and generative functions, at least a few of them. Remember, I will tell you here, recurrence relations, I don't want you to solve, but use the substitution technique. All right. Yes, again, right, click is always complete graph. Yes, you are having a problem here. Let me explain one question here. You are not leaving me today. I'm just explaining, you are not leaving me today. Why are you worried about much here? Study. Before the exam, you can't learn. Even I explain, you will forget it. Click. Okay, somebody want, click is always a complete graph. We say click of given graph. It is maximal connected complete subgraph. So many words are there here. So you should know what is a subgraph. You should look at inside, and that subgraph should be complete. And that complete, of course, connected word is not required because I use the word complete. So I'm deleting this word. Maximal complete subgraph. And it should be maximal. These three words you should learn before knowing about the click. Suppose I want to give something here. Look at these clicks. You have so many clicks here. This is a graph. A, B, C, D, E, F, G, H. How many clicks you have here? So many clicks. What should I do, Yadav? Please take my name. What is your name? Strongly connected graph. I'm coming for that. Okay, let's come to here, yaar. What is a click? See, ABC is a complete. You can see that ABC is a complete graph, but this is, it's also subgraph, it is also complete graph, but it is not a maximal because there is another vertex which can make a K4, yes or no? That is a K4, So here, this is called as a click. This is one click. There is another click, C and E, which can form another click. That is K2. This is a K2, this is a K4. And there is one more click. This is K3. This is another click. And FH is another click. There are total 4 clicks are there here. Everyone? How many clicks are there? 4 clicks. What is the click definition? It is a subgraph and it is also complete graph, but it should be maximal. So here if I take CE, using CE, I cannot make any other complete graph except K2. If the K3 is forming using CE, then this is not a click. Yes. So total there are 4 clicks. Yes. Total there are 4 clicks. Okay, don't worry much. Somebody is asking, I'm going to leave now. Last one, the strongly connected component. I don't want to teach here, but you are asking me to teach. I'm going to leave now. Just 5 minutes left. strongly connected components. Okay, look at now they might ask strongly connected components. If B and D does not have an edge, if B and D does not have an edge, then if B and D does not have an edge, this ABC is one click and ACD will be another click. There will be two clicks here. There will be two clicks. If you don't have this edge, then this will be one click because K3 and this forms K3. So there will be two clicks, guys, if you don't have this edge. Yes. Okay, now find out the strongly connected component. So what is strongly connected component? It is a subgraph. It is a subgraph, that is a maximal subgraphs where every two vertices have the path. Every two vertices have path in both directions. Now look at this one. If you take this one, A, B, C, A, and if you look at this cycle, every two vertices, they have a path in both directions, but that is not a maximal subgraph. Let me write the definition too. Maximal subgraph where every two vertices have path in both directions from U to V and V to U. Now subgraph is fine and that should be maximal. And now look at, if you take these three, still I can add one more vertex. I can have D. Now these four vertices can form strongly connected component because here every two vertices have a path. You can't add E because E to C there is no path. But look at these two vertices. Every two vertices of these four vertices, you will have a path in both directions. And CE you can't have component. But this two, yes, is another component. And G alone, because G to anybody you don't have it. Now look at that. There are three strongly connected components here. There are three. Every NP complete problem is decidable. Who is Parek? Every NP complete problem is decidable. Every NP problem decidable. Do you know that? What are the questions you are asking now? Without knowing NP complete definition, every NP complete problem is decidable. Remember that. NP complete means you have halting program. Every NP problem is decidable. All right. All NP problems are decidable, guys. NP hard, it may or may not, but NP complete is in NP, right? Also it is in NP hard, that's fine. Three strongly connected components here. Three strongly connected components. All right, what you are doing? Okay guys, I'm going to close the session and please learn it. So look at inclusion exclusion principle. You might be knowing in Venn diagram, you might be used many times and use it even for three sets also you might use. And remember the permutation formula, and you should know with repetition, without repetition. Please look at with repetition, permutations, without repetitions, and combinations, without repetitions and with repetitions. Yes, repetitions allowed. Yes, everybody, repetitions allowed here, it's not allowed here. And please look at that, and you remember the binomial theorem to find the coefficients. Please remember it, but I'm going for which is generating functions. And I'm not going to teach, but who have studied already, please look at it. Remember 1 by 1 minus x, which is a famous generating function closed formula. This is a closed form. The series is 1 1 1 1 1 series, guys, and the series called as it is 1 1 1 infinite series. And that can be represented as 1 plus x square plus x cube plus and so on, which is a closed formula is 1 by 1 minus x, and this is going to give many closed forms for other series, right? So remember this point. And the second one, if you do the differentiation, you are going to get a different sequence. Look at that, 1 2 3 4 series. For that you get 1 by 1 minus x whole square. But if you want to get this, you have to remember 1 1 1 series, guys. If you know this, then you can do the differentiation. You can get, look at that, this will become 0, this will become 1, this will become 2x, this will become 3x square. Then this can make the 1 2 3 4 series. This is x power 0 coefficient, and this is x power 1 coefficient, and x power 2 coefficient, and x power q coefficient, x power 3, whatever. And if you want to remember this, very difficult, but if you want to prove it, it can be easy in the exam, guys. So those people who are trying to remember the closed forms, maybe not easy. Even I can't remember what is the sequence for 1 by 1 minus x square. I can't remember. But if you know this, you can always prove this. Not only that, let's look at these are the very important closed forms. What you have, the 1 1 1 1 you have, then 1 by 1 minus x. Then if you have 1 minus 1 1 minus 1, then this are going to be, look at the series is going to be equation 1 minus x plus x square minus x cube plus x power 4. This can be proved as 1 by 1 plus x. And if you want to remember this too, these are very important for you. You can remember the first and second one, and remaining all can be proved easily, and third and fourth are also similar. And 1 by 1 minus ax series, here 1 dot x is there, here ax is there. So because it's going to come here a square, a cube. So this can be written as 1 plus ax whole square plus ax whole cube, and in place of x you got ax here, that's all, which are basically similar, 1 and 3. Here in the previous one, a was equal to 1, so we got that. So if you have not studied generating function, I don't recommend to study now. But if you are already practiced, look at how to remember it. And next one, the second term, every alternate term is going to cancel. Now you get 1 plus x square plus x power 4 plus x power 6. By taking the commons and so many things, you will get 1 by 1 minus x square somehow. Okay. Now look at that, how to get another kind of a closed form, 2 by 1 minus x square. So what we have 1 by 1 minus x, we have 1 by 1 plus x. If you do the addition to them, then you get a new series 2 comma 0 comma 2 comma 0 2 comma 0. This series is going to give you the sum of these ones. And when you practice lot, you can understand how to get this series right. Everybody? So I don't recommend, if you are studying first time, this kind of sequences are not possible. And many people have asked in the previous session, sir, how to solve the recurrence relations? Why do you want to solve in the exam? In case if you want to solve, you have, a linear, non-linear, homogeneous and non-homogeneous, so many types of equations are there. So this is a linear homogeneous equation. You have the two base conditions. You have some linear. You have this is a linear. Are you going to solve this in the exam? Right. First find the characteristic equation. If you find this, you will get r square minus r minus 2. For this, if you find that, you will get the roots r1 is equal to r2 is equal minus 1. When you have that, you should know how to write the solution. This is a solution. You have two different roots, so you are going to write this way. If you have the same roots, you will write different way. But are you going to remember all of them for the exam? I don't know. That is c1 dot 2 power n, because one root is 2, other root is minus 1. So c1 dot 2 power n plus c2 dot minus 1 power n. So this solution, we don't know c1, c2. We are going to calculate using these two base conditions. Use this to calculate the c1, c2. So a0 is already given, that is 2. So put a0 here. a0 is equal to c1 plus c2, you get it. that is 2, and A0 E1 you are going to calculate, and there C1 plus C2 you get two equations and find out what is C1, what is C2 and substitute them, you get the final answer. But are you going to do this in the exam? If you do any mistake, are you going to get any answer? If you don't know how to write the solution, so those people who have practiced well, please use this. How to write first characteristic equation, then how to find the C1, C2, then how to write the final solution. 3 steps we have. First, how to find the roots of the characteristic equation of this one, and second, how to find the C1, C2 using the base conditions, and third, how to write the final solution. Yes, 3 steps you have to use, but I don't recommend, guys. Okay, so there are so many types of linear, non-linear. I don't want you to talk about. Yes, this is what I have done revision for you, and those things which you feel easy, please remember them. Those things which you don't know, please don't study now. So all this, efforts, I have made it only to revise those people who have prepared, and if you have not prepared any concept, please ignore. If you don't do any topic, that is not going to affect your rank, remember that. But try to study as many topics possible. I believe that you have studied so many topics, and this revision definitely helps you if you have done already. But discrete mathematics, even you don't study that, still you can get the top rank, even top 50, right? I have left so many topics in discrete mathematics during my preparation, still I got the good rank, right? So remember that any subject that we are doing revision or we are trying to do the practice, that is only to enlighten before the exam what are the important concepts of the subject. Okay, how to solve reconciliation, ये तो बताया ना यार इनको, क्या यार यही तो है ना टेक्निक, एक एग्जाम्पल इसलिए दिया, अभी जाके पढ़ोगे क्या आई लव इंडिया, राइट ना, हटा दो दिमाग से, अभी जाके नहीं करना आपको. All right. Yeah, thank you, Sri. Yes, how many of you have enjoyed these sessions from the last? This is the 4th subject I made a revision, and also yesterday I made for all the subjects few concepts. How many of you enjoyed these sessions, guys? Because I want your feedback, and after the video, please go back to the previous videos. Please comment every video what you have enjoyed. Remember that your comment is, that is what you can give to me, and I don't expect any prize from you. The only appreciation is please like the session and also comment every video that you have attended, guys. And I have to see today. Yes, no, I love India, right? Shortcut is the substitution. Yesterday, please watch the yesterday video. Shortcut is a substitution. Please comment every video what you have learned in the previous sessions, guys, right? This is the 4th subject that I made a revision, but I want to make every subject the revision, but I don't have the time, guys. I'm worried about it because I joined the Gradeup very late. I'm so sorry for that, but if I have joined before 10 to 15 days, I could have done many things. Yeah, I'm sorry for that. Yeah, thank you so much for attending every session. Please don't forget the comment. Please comment it, and we have 1 day left, and I'm going to come back at 6 p.m. with more energy. Right now I lost my energy, but still I'm keeping my attention on you guys. Thank you so much. Yeah, Jagruti, thank you. And we have very good educators, and so many might be joining in future. You do not know about it. Yes. And I want to see everyone who are attending here. I want to see here because you are following my classes. I will keep you here if you are going to get the rank. You are going to meet me definitely. Remember that. And please join the Gradeup Super, and the batch is going to start on Feb 15. Yes. Yeah, thank you so much. And also we are going to give you the post guidance based on your rank. So don't forget to follow our videos and install the Gradeup app and follow us. Yes. And don't forget to like the session, and don't forget to share, and don't forget to subscribe, and don't forget to comment the session, guys. Yes, thank you so much for joining this session, and never ever forget, you are the best in your world. Remember that. If you have created your own world, in your world you are the best. Remember that. All right, Selvi. Yes, please respond what you have done in the past 4 days. Have you enjoyed? All the best, everyone. Please meet me at 6 p.m. I'm not going to teach anything at 6 p.m. Just I will enlighten how to attempt the GATE exam paper. How to attempt the GATE exam paper, guys. Please like the session. Don't forget to like the session. Yes, please go back to the yesterday video and please go back to the previous videos. Please comment what you have learned. Just I need your feedback, what you have learned from me in the last minute, that I want to know. Yes. Thank you so much, Ranjan. Thank you so much. Yes. Yes, all the best everyone. All the best everyone, and come back to the 6 p.m. today. We'll discuss, Thank you Sneha. Rahul, thank you so much. JPT, thank you so much for joining the session. Thank you. Yes, you can take rest and you can leave now. Your session is over. Yes, just I am discussing with everyone who are following my classes. Yes, thank you so much. Yes, Yogesh, all the best too. You too. Yes. Yeah, thanks Reena. Thank you so much. Just saying one thank you can make me I can feel happy. If you are going to give just thank, if you say thanks or if you give any comment, right? Likes anyhow not visible, but like count is visible. I can see that how many are liking. That is that's enough for me. But say just thank you so much. Yeah, Jagruti, thank you. Samiksha, thank you. Yeah, see you guys. See you at 6 p.m. today. Yes, Sri. Yes, my blessings always there to everyone. Yes, as long as you are with me, then definitely I am always there with you. Never ever forget me that I am always with you. Yes. And also after the exam, don't forget to send a message. Any question you remember, please send a message to my number. If you want my number, remember that guys, 9911691155, 9911691155. After the exam, please send the questions that you remember. Immediately send on WhatsApp. I will take up them. I will discuss on videos, guys. Yes, Sneha, thank you. Yogesh, don't worry. Give the best. You have one day more, and tomorrow just perform whatever you have learned. And then tomorrow you are not going to learn anything. Tomorrow you are going to test your knowledge. Remember that. Anyhow, I'll be coming back at 6 p.m. I'll be talking many things. I'm going to talk about tomorrow. Just it's half an hour session. I hope 20 minutes to 30 minutes. I'm going to talk about how to how to perform well in the exam. Okay, tomorrow I'm going to for the tomorrow's exam, I'm going to give you some guidelines. Please come to the session at 6 p.m. today only. Yes, Govind, I marked your name. Yes, at least 1 rank. If it is not, then at least get 100 rank. Within 100 rank is also equal to first rank, guys. Don't forget that. Yes, thank you so much. Bye. Take care. See you in the next class at 6 p.m. guys. Bye. Don't be scared, Ranjan. Bye.